binary based question is that the register stores the following binary number 11001101, and that sounds pretty good actually. The binary value in the register represents an unsigned binary integer. You have to convert the unsigned binary integer into denary. So now the first step is what I do is this is an old table technique. You guys can follow any technique you guys like. I just follow this kind of technique when dealing with these type of questions. So I write these numbers in top, and since we have to convert this binary integer into denary, you just add everything, the values on the top with 1 below them. So 128 plus 64 plus 8 plus 4 plus 1. These are all values with 1 at the bottom. So we can add all of them since they are active, or let's say. So that's going to give you an answer of about 205. That's going to be answer for about 1 mark. Then the next part is the binary value in the register represents, let's say, 2's complement binary integer. Convert the 2's complement binary integer into denary. So since this is 205, we have to convert this into 2's complement. So what we're going to do is 2's complement is you have to inverse the digits. So what I mean by is if it's 1 1 0 0 1 1 0 1, you're going to switch all the values, which is going to become 0 0 1 1 0 0 1 0, and then you're going to add a positive 1 to that, and it's going to become 0 plus 1. That's going to become a let's say a carry of 1 but a positive 0, carry of 1 but a positive 0. This is going to become 1 plus 1. Actually, sorry guys, 0 plus 1 is just going to become 1, so that's not going to make any difference to it. Even if you switch the values together, it's going to become 1 1 0 0 1 1 0 0. So if you add all these values together, actually you should be getting a negative integer in this form. This should be 1, this should be 2, this should be 4, 8, 16, and 32. So if you add 32 plus 16, that should give you roughly about plus 2 plus 1. That should give you about 51. Since this is an inverse, this is going to be a negative 51. This is going to be your answer for about 1 mark. Since you add 32 plus 16 plus 2 plus 1, that's going to give you 51. Since it's 2's complement, you're just going to switch it off, and you're going to put negative symbol there. It's going to be for 1 mark. Now the binary value in the register represents a hexadecimal number. Convert the binary number into hexadecimal. So what I do is, since we know that 1 hexadigit is about, let's say, 4 binary digits, this is going to split the value into 2 parts. So what I'm doing is I'm just splitting this into 4 parts, and on the top I just write 8421 8421. So I split them again into separate columns. This is going to be 1 here. This is, by the way, let me just write this down better. This is 1 here as well. And we just add everything with 1 at the bottom. So we have 8 plus 4. Actually, I'm just going to write it down here so that you guys can see. 8 plus 4, this is going to become 12. 8 plus 4 plus 1, this is going to become 13. Now in the hexadecimal table, everything is from denary, let's say from 0 to 9. Everything in hex is also from 0 to 9. If you move past that in denary form, 10 to, let's say, 10 to 15, I think approx, it's A to F. So that means this is going to be, 12 is going to be, let's say, 10, 11, and this is going to be A, B, and 12 is going to be C. 12 is going to be equivalent to a C. 13, however, is going to become equivalent to a D. So that means your hexadecimal notation is going to be C and D. That's going to be your answer in terms of hexadecimal. You guys can use any method you guys like. This is just a method that I use where I split it into 4 binary digits and 4 binary bits. 1 hex is equal to 4 binary digits. So this is going to be CD for about 1 mark. Stated by the value in the register cannot be interpreted as binary coded decimal, or also known as BCD system. Now the main reason is because the denary value, let's say the denary value in each group of 4 bits, let's say in 4 bits, it's greater than 9 itself. Or you can mention that the denary value in each nibble is greater than 9 for about 1 mark. Now the binary contents of two registers are shown. You have to add the contents of register 1 and register 2, and you have to show your workings. So I'm just going to show the workings: 0 0 1 1 1 1 0 1 0 0 1 0 1 1 0 1. So you're going to clearly add this up together so I can show you the value. And yeah, we have to add the contents together. So 1 plus 1, this is going to become 0 with a carry of 1. And this is going to become 1. 1 plus 1, that's going to become 0, carry of 1. 1 plus 1 plus 1 is going to be 1 with carry of 1. 1 plus 1 again is going to become 0, carry 1. 1 plus 1 plus 1, that's going to become 1, carry. Actually, yeah, that's going to become 1, carry of 1. 1 plus 0 plus 0, it's going to become 1, 0. So, in this case, we have added the contents of the registers, so we can see all the carries of 1 we have shown at the top, so that we know that's carry of 1 in that case. So this is going to be your final value. It's going to be 0 1 1 0 1 0 1 0. That's going to be answer for about 2 marks. All you need to do is just, it's 1 plus 1 is just going to become 0 with a carry of 1, and that's going to be your final answer: 0 1 1 0 1 0 1 0. Okay, that's for 2 marks. Let's move on to the next question. Subtract the contents of register 2 from the contents of register 1. Now this is an interesting question. Actually, do pay attention for this one, is because this is where we're going to apply 2's complement to those values that are going to be stored in register, let's say in register 2 in this case. So what I mean by this is that since you have to subtract the values in register 2 from register 1, what you're going to do is you're going to apply, this is going to be a plus, but you're going to apply 2's complement to this value stored in register 2. So what I'm going to do is I'm just going to write down what register 1 and register 2 values are going to be stored. So I'm just going to do the working here so that we can see it better, the questions. So this is register 1. I'm just going to be checking the values closely so that we can analyze how this thing works, because it's very critical that you guys understand this type of concept when dealing with these equations. I'm sorry, not equations, this is not physics, this is actually computer science. When dealing with these numbers, register 1 has binary value 0 0 1 1 1 1 0 1. I just got this from the question above. Let me just write that down neatly so you guys can see this. 1 1 0 1. Register 2, however, is more like 0 0 1 0 1 1 0 1. Now register 2 is where we're going to apply 2's complement. Now this is very important that you're going to apply 2's complement to this. What I mean by is, first of all, we're going to switch the values here to 1 1 0 1 0 0 1 0. Switch, 1 becomes 0, 0 becomes 1. That's how we have done this. So we just inverted it. And then add a positive 1 to that. This is going to give you 1 1 0 0 1 0 1 1. Just add 0 plus 1. That's going to give you a positive 1. Now, in this case, what this means is, since we have done 2's complement to this, all we need to do is just add the values of register 1 to the values of register 2 with 2's complement. So even though we're doing subtraction, we're technically doing, let's say, we give an example of 2 plus negative 2. We're just doing something like that form, where negative 2 is just 2's complement. It just means the same thing as 2 minus 2. So that's just the same thing as subtraction. So that's the idea behind us doing 2's complement, so it's easier for us individually to do that. So we just need to add these two values together, and that'll be equivalent to subtraction form. Once you add this value stored in register 1 as well as 2's complement values register 2, you're going to get 1 plus 1. That's going to become 0, carry 1. 1 plus 1, 0, carry 1. 1 plus 1, 0, carry 1. 1 plus 1, 0, carry 1. 1 plus 1 plus 1. 1, carry 1. 1 plus 1 plus 0. This in case is just going to be 0, carry 1. 1 plus 1, 0, carry 1. 1 plus 1, 0 carry 1. This by the way, this outer part is just going to be ignored, so don't care about that part. Is just this part's just going to be canceled. Your final answer in this case is going to be, your final answer is going to become 0 0 0 1 0 0 0 0. This is your final answer for this question on top when dealing with subtracting the contents that is stored of register 2 from the contents of register 1. Okay, 0 0 0 1 0 0 0 0. All right.